Welcome, everyone, to Mark Voids a Warranty. I'm Mark, and I'm here to void a warranty. And today we've got a very exciting project, the Casio Portable Printing Calculator. I found this at a local office supply store, and I just need to know what's inside. But I've been moving my office around, don't know where all my screwdrivers are. There's a good chance this one can end badly. We'll find out. Sorry about the last-minute stream delay or change. What happened there was that I was getting ready to start the stream, and I accidentally double-clicked the mouse, which started it, and then the mouse happened to be in the right spot to end the stream at the exact same moment. So somewhere out there is a stream of like half a second of nothingness. So that was my bad. Definitely my bad. All right, so let's see what we've got in front of us today. Get that keyboard out of the way. We don't need that for the time being. So this is our calculator. Brand new, brand spanking new. Looks like it's got a few different functions on it. You know, you can print some memories, some costs, sell margin. Is this for stocks? I don't know. Or maybe it's how much you're paying for it, or how much money you're going to be making off of something. Reset button down at the bottom, and 4 little screws. So up in the top, we've got a piece of cardboard. All right. Spot for a little tiny thermal roll. Let's get the sticky part undone and see if we can't figure out which way this goes in. I would think it feeds that way. I don't know. But before we destroy this, I guess I should get my camera moved. I've been rearranging the office, putting in new lighting, moving around workbenches and stuff. So sorry about that. Hopefully make a little more progress this weekend. I hate to deprive you of mark time on camera, right? Who would hate to miss that? I know I would hate to miss that. So let me get this thing plugged in. We've got a spare port down here on port 7, I think it is. Let's see. Maybe 8. Let's see what happens when we power it up. Ooh, fun. Also need to make sure my peeps found the new live stream. Thank you, Paul Daly, for fixing that for me. I do have the comment section open. If you guys want to add anything, I would be more than happy to make comments as I go through here. One of the comments is okay, people wanting to know where the stream is. I'm going to mute them. Let them figure it out. And we're going to get back to playing. See if we can't get that in there. Maybe that doesn't go in there. That is a possibility, but I see a roller. Feed. Does it move? Maybe not. Maybe you just drop it in and it figures it out. I don't know. That doesn't seem to make sense to me, but let's see what happens. Oh, people. You're going to make me read the manual, aren't you? Reprint function, easy to read. Does it give me a manual? It does. Boy, you know, I hate voiding warranties before we at least get a chance to play with it for a minute. All I want to know is how you load the paper. Everything else, is somewhat irrelevant on account of the fact that I'm going to destroy this in just a minute. Okay. Ink roller, loading paper roll. Take off the cover. Okay, I did that. Lift up the little thing. I did that. Maybe it's got to go over like this. Let's see if that does it. Let's find out. $400 equals $1,200. Print it. Print it. No. Okay. Is it feeding? It's not feeding. I don't have it hooked up right. What are we doing wrong here? Let's try it this way. See, I really feel like it needs to go into something. You know something? Screw it. Too complicated. That's what you get for wronging me, calculator. You made me feel stupid. I can't have that. I've got a reputation to protect. And you know something? Typically for something like you, I might use the brass hammer, show a little respect. I might use the drilling hammer, show a little bit of moxie. But no, I've just got the 3-pound sledge. Yeah, that's what's in your future. See, one of the things people don't understand about electronics is that every now and again, you need to beat one to death and then plaster it on the wall of your office and leave it there as an example to the others. Otherwise, you're going to start getting them to, they start acting up. They get all bossy. I don't know if you've seen a documentary about this, the end of the world. It involves a computer system called Skynet. That's because engineers like me weren't around to put it in its place. I'm telling you, people, trust me. Trust me when I tell you, you need to do this too. All right. So we're just having a little fun here, taking these things apart. So there's 1 screw, 2 screw, 3 screw. See if there's any hiding inside. I don't see any. I don't know if you do or not. Sometimes they'll put some under feet. And the adhesive stayed behind, but it looks like they didn't do that here. So those are the only 3 obvious screws. Oh, yeah. All right, so we've got a print module that is connected in kind of a weird way. Let me make a quick adjustment here. When I unplugged to plug in, I lost my video feed. And I need that back to know what camera I have and whether or not it's active. All right, base of the camera, all plastic, nothing exciting. You've got some, 4 AA's. This thing will run off 6 volts. All right, so here's the thing that was giving me such grief. And it's connected in really an interesting way. I'm going to put the wires down so you can see it. My suspicion is the way it's made this way is the assembly line it was constructed on. It had people in different parts. They had a mechanical module, and they soldered the wires onto a little carrier board that just connects them over. And then there's a flat ribbon cable that I just cut through that connects to the rest of the board. So nothing too exciting here. This is, why was this giving me such grief? Probably because I didn't take the time to read the manual properly. Nope, see, that is where you feed it in. I was right initially. I just couldn't get the paper in there, probably because I was impatient and looking for a reason to use the hammer. We've got a spring-loaded. Okay, so we've got a couple motors here. So one, we've got just a simple DC motor, and that takes care of advancing the paper. And actually, so what we've got, and let me get you to a closer camera. That's the microscope one. Come to me, Mr. Microscope. Show me the secrets in the board. So we've got two little rolling print heads, and the motor seems to be able to control those. Right? So these are all the characters that this thing can print. So this isn't a thermal printer after all. This is an ink printer. Interesting, interesting. Then we've got a stepper here, or what it looks like to be a stepper. I could be wrong. Probably do better for you having you on this camera next. Where is the camera? So this is the DC, just the simple DC motor. And this one is what looks to maybe be a stepper motor hiding inside. So that one must control where this carriage goes. And now that I know there's ink, which I did see on that paper earlier, I wasn't sure what all I'd gotten into. We got to be careful we don't get into that. Interesting, interesting. Okay, well, let's see what it takes to get this apart, if it does indeed come apart. Let's see what makes this thing tick, shall we? And we're going to get this to a location that's a little easier for me to get to. All right. We are smashing stuff. Electrical engineering by itself doesn't really exist much anymore. So much of what we do is integrated with our mechanical counterparts or other disciplines. So inside, we've got a simple planetary gear setup, it looks like, which is a good way to transfer torque in a small amount of space. So we've got that apart. I bet you these other gears are pressed on. There's a little indexing pin there that I'm interested to know what it does. Little timing gear. I don't know. Interesting, interesting. Don't worry, we will use that sledgehammer. After all, this did make me look to fool on national TV, right? Actually, international TV. All right, so here's something interesting. We've got a coil here. So a sensing coil, there's a piece of metal that spins around, and I assume one of those has a magnet on it. Or maybe it's magnetized. So a sensing coil then keeps track of probably the line feed. So did they get that motor to do double duty? Maybe. All right, what else can we take apart here? What else? Come on. You know you want to. Here's something interesting. We've got a spring spun around there down at the bottom. That must be the return. Is that a return? I don't know. Yep, that's the return. I haven't seen that before. That's clever, clever, clever. Ha ha ha. Okay, so get off there. Oh, there must be another spring. That thing still wants to go back. Oh, that must be the one on the other carriage. Come on. All right. As you can see, those things just slid right off. All right. So nothing else really electrically interesting there. The motor is still in there. Let's see what else we have. Now, I know what you guys are thinking out there. Mark, you just destroyed a perfectly good calculator. I say this all the time, guys. Don't even worry about it. I mean, I could put this back together in like 20 minutes. Don't even sweat it. I do that with a lot of the stuff that I take apart. You know, I take it apart on TV, but then, you know, I don't want to go just fill a landfill. So I just put it back together. It's not a big deal. Interesting, interesting. Okay, so what about that other thing that we saw? Okay, so that thing that I saw wasn't a brushless DC motor hiding inside. It was this. It was what looks to be a photocell. So this whole thing that's pretty crazy. So they figured out a way to drive this whole thing off of a single simple DC motor. Index where all the little digits go. Now, we're an electrical engineering channel, not a mechanical engineering, so we didn't really take the time to go and look at all of those gears and how they're working. But they figured out how, just with the direction of the motor, how to set, reset, how to slide those digits across, how to drive them, all with rotations. Kind of like if you've ever taken apart a padlock, you know that if you spin it so much one way, then so much another, and then so much the other direction, you can start driving these different cogs and driving different things. So really clever on their part, actually. Because a brushless DC motor is cheaper than a stepper motor by a lot. Okay, so next up, we've got just a simple, where's my camera? Just a simple barrel jack, DC barrel jack connector. Looks like we've got ground, positive, and two positives. Oh, I bet you it's a switched connector so that when you plug in the DC, it disconnects the batteries. That would make sense. That way you don't have two power sources. We've also got some make-break connections. I really do like using these. What I'm looking at are these little pads with slits in them and a trace. So if you're doing prototyping or you're having trouble getting it to work or you need different functionality, you basically just take an X-Acto knife and just slice through that copper trace. And then if you need to re-enable it, you just create a solder ball there. Super simple. We've got a chip on a little blob on board. So underneath this blob of epoxy is a silicone die. And they've just put it right on here and done the wire bonding out to pads and then covered the whole thing in epoxy. If you've got the process control to make that happen, it's cheaper than going out and buying an integrated circuit. All of these calculators have ASICs in them. application-specific integrated circuit, right? They're not going out and programming microcontrollers for the large part. They're getting custom silicone that only has the gates that they need. It only has the transistors they need, because you do pay by the transistor, so they really minimize them. A little clock timer there, little crystal. We've got some plastic doing something. Oh, where did my chat go? How weird is that? Or maybe there is no chat. I don't know. I thought I saw a chat earlier, but as you can tell by the fact that I even have a different stream ID, I had a little trouble getting going this morning with the computer. All right, we need to get this thing out. See what else we can see. Interesting, interesting. Okay, so I'm having a little trouble getting those switches out. There are stickers that were expertly placed here. I really doubt anything's underneath those that's holding this board in, but I'm not terribly sure. Nope, doesn't feel like anything. So then the question is, how do I get that out? Is there a screw I'm missing? Oh, you know what it is? Okay, I think I know what it is. So these little plastic retainer rings, what they've done with these is melted them over to hold the board in place, right? You don't need a fastener. You just need some guy with a soldering iron and a cheap tip just comes through, melts the plastic, and it acts like a rivet. As my dad used to say, clever, clever toilet lever. Oh, look, it just comes right out. Comes right out. I know you're thinking it sounded like you cracked the board a little. Okay, maybe a little, but a little bit of super glue and ramen, that'll go right back together. Don't even sweat it. Don't even sweat it. All right, so on the back side, we've got a ton of conductive pads. And a lot of times what you see with these, this is really interesting. I'm really actually learning a lot taking this thing apart. So these traces are resistors. A lot of times what you'll see is that there's actually two conductors, and you use the button to create a short circuit between the two conductors, right? These pads will sit there on it, but look what they've done here. It's a single conductor. So when you press that down, you're creating a short circuit that lowers the resistance of that switch. That is clever. That is very clever. Come here, Chester. I know. Everybody on TV says hi, Chester. So that is really neat. I don't know that I've seen that before either. These guys are really going out of their way to save money. That's pretty impressive. Personally, I like to think they would have used a stronger PCB laminate material that would stand up to my rough housing, but you know, hey, who can have it all? Okay, what else do we have here? Electrolytic capacitor. It's just a reservoir cap. It looks like we've got some surface traces. Where is this? Just some jumpers. So they couldn't have a second layer of on the backside running traces because they had all those things there. So here we've got a few surface traces. And again, the really interesting thing here are these make-break pads. I really like those. Looks like we've got a reset switch. This is the more common way that you see those those types of pads implemented. So here you've got two separate conductors, and it connects them for you. A 0 ohm jumper. So that's how they ran their surface traces. So they ran them trace to trace as much as possible, and then when they couldn't, they did some surface connectors. There's no programming to be done on these. Again, they do everything at the silicone level. So there's really, I mean, there's tests that you can do to make sure everything got connected correctly. That's what all these pads are, you know, P77, P76. But other than that, it either works or it doesn't. There's no firmware upgrades, nothing. Very interesting stuff. All right. Well, that is about all that I see on this particular device that is all that interesting. Single side surface mount, that is the cheaper way to go. They made life easier for the assembly people by making a, you know, a little carrier board to connect things. That's kind of clever too. That just makes assembly that much easier so that you don't have to have somebody worrying about getting the colors right. You just have one person doing all the colors, and then you can have 100 people attach those. I like that. That's process engineering. And then the other interesting thing that I really like is this. They had all sorts of movement coming out of just one simple DC motor. Right. They were advancing the paper roll. They were picking which character they were going to use. They were picking where that character was on the screen, all with a single motor. That's clever. Ooh, and getting the, you know, once you get the character that you want lined up, getting it to hit where you want it to hit. I mean, they had all sorts of motion in there. Maybe I'll put that back together. See, you know, see if I can understand it a little more. All right. Well, let me give you guys a second to ask any questions that you want. And other than that, I'm going to end Mark Voids of Warranty a little early today, which is, I know, unusual. Usually I run over. But for that, I need to figure out what YouTube did with my comment stream. It is everything's behaving so peculiarly today. Edit, maybe? No. I don't know. It's my comments are gone. My stream started and stopped. And my in-stream button's in a different spot. I don't know what's going on. But anyhow, since I can't communicate back with you, I'm sorry about that. But I do hope you enjoyed Mark Voids of Warranty. I'm Mark. I voided a warranty. Anyhow, if you do have any suggestions for teardowns, if you know there's anything you want to see destroyed, if there's anything, a special hammer you want me to use, let me know. Leave a comment below. Other than that, I'll see you next time. Take care. Bye. I think we're ending. I don't know what's happening. I clicked end like 3 times. This could be in the prologue. I don't know. I said end. I really did. I'm clicking it again. This is sad. Let's try it again. In stream. Yes, I would like to in stream. I really don't know what's going on with YouTube today. End. I think I'm going to have to close the window. End stream. End. Stop stream. Okay, we're still in Mark Voids of Warranty because it's not letting me end it.